Hi there. So we finally reached the third form of the linear function, the slope-intercept form. In previous videos, we've looked at the standard form, at the functional form, and so this is the third and last form of a linear function. So if you haven't seen those videos, please check them out. They're on the playlist. And let's get started. So this is the slope-intercept form of a linear function. Y equals m times x plus b. And it's basically similar to the functional form, where instead of writing f of x, here we have y, because we are looking at the plane. So this form is very helpful for graphing or from getting the function out of a graph. So let's look at this form. So we have x, which is our variable, right? Which means x changes, its variable, and it's actually our independent variable. Y is our dependent variable. So y will change as well, but it will be dependent on x. And that is the usual format for functions. We're left with this letter here, m, and the letter b. So let's figure out what these are. Well, if we look at b first, this is actually the y-intercept. Why is that so? Well, let's look at this example right here. The y-intercept of a function is the point where the function or the graph of the function intersects the y-axis, right? This is the y-axis, and we're looking at the point where it intersects. So that is right here, right? What happens when a graph intersects the y-axis? Well, the important thing to notice is that because it's on the axis, it's right at x equals 0, right there, right? So at this point, x equals 0. And we have our y-intercept. Now, if we use this, this point in our slope-intercept form, we can write y equals m times 0, right, because we're at the intercept, plus b. Now this is our intercept, right? This is where the graph cuts into or intersects the y-axis. What this means is that b is our y-intercept. Okay, so b is our y-intercept. We understand that. Now let's look at our m. Now let's say that we are going to change our x from 0 here to 1. So x is going to go from 0 to 1. In that case, y is going to go from b to m times 1 plus b. So y changed by an amount of m, right? It was b, and now it's m plus b. Now let's change x from 1 to 2. In this case, y will go from m times 1 plus b to m times 2 plus b. So again, each time when x changes by 1, y changes by m. So m really is the rate in which the y value of the function changes every time we change x by 1. And so that's why it is called the rate of change, and it's also basically the slope. If we move x by 1, we'll move up y by m. Okay, so that defines our slope. So again, m is the slope. Now, we also saw another way of calculating our slope, not by using our intercept, but by looking at any other points on the graph. And what we saw was that we can actually use this formula where we take 2 points, say this point and this point, and we evaluate, we can see what y is and what x is on both points, and we can evaluate m. So if we look here, our y is 1 1, 2, 3, 4, 5, 6, right? And our x is 1, 2, 3, 4. So it's an ordered pair of 4 and 6. Here our x is 2, the slower one, and our y is 2. Okay, so if we use this formula now, m equals 6 minus 2, right? These are the two y's. 6 minus 2. Divide by 4 minus 2 equals 4 divided by 2, which equals 2. So we get that m equals 2 in this case, our slope. And this is what we saw here too. When we moved by 1 here, we came up from minus 2 to 0. If we go another 1 in x, we get up to 2. We go one more in x, another 2, and so on. So again, m is the rate of change, which can be measured if we know, if we can count units of x, and then the amount that y has changed, we can calculate it that way, or we can just see it in the form of our function here. Now, this form for the linear function is very, very useful because we are often looking at the intercepts and the slope to learn things about our problems. So when we're looking at a linear function that describes some kind of physical property, or maybe the pricing of something, like we've spoken about before, for instance, the pricing of peaches, the weight of pennies, all those cases, m here, the rate of change, will tell us how much y will change, how much we have to pay more, or how much it weighs more every time we change our independent variable x. So I hope this was helpful, and if it was, please like. Please check out the other videos for linear functions. They're all linked in the playlist, and I will see you next time.